Hi, this is Sravan Kumar, Department of ECE from the St. Peter's Engineering College. Today we will discuss about the electronic measurements and instrumentation. So first, what is meant by measurement? So measurement is a process of determining some unknown quantity compares with the known standard value. Known standard quantity or this is called as a measurement. So next one is the what is meant by instrument. So instrument is a device can use for measure any quantity. Instrument is a device we can measure any type of quantity. So that is called as a measurement, and so this is the definition of measurement. So measurement is the process of determining the size or magnitude of some unknown quantity compares with the known standard quantity. So next one is the instrumentation. So instrument is a device you can use for measuring some any type of physical or electrical quantity. So those are such as temperature, pressure, force, or any type of quantities. So that is called as a instrumentation. So next, this one is the block schematic of instrumentation. So in this block diagram we have different types of blocks. So that one is the first one is the primary sensing element, second one is the variable conversion element, third one is the variable manipulation element, fourth one is the data transmission element, last one is the data presentation or controlling element. So in this block diagram we will discuss about the first one is the primary sensing element. So in this electronic measurement and instrumentation, initially we can discuss about the different kind of instruments we are used for measuring some any kind of measure values. So just like here we are using previously, you can measure temperature, you can measure pressure, you can measure force or any type of quantity. So we are using different types of instruments for measuring any type of physical quantity. We can use primary sensing element. So in this primary sensing element we are using the sensors for sensing the any type of physical quantity, any type of physical quantity. So these sensor you can call it as a transducers, or we can call it as a transducer. So what is mean by transducer? So transducer is a device, it converts one form of energy to another form of so for example you can measure this physical parameter as a temperature. So for example, how we can measure this temperature in the room area? So for those we can use temperature sensor. So this sensor senses the temperature value of the particular area or particular room. So those value or those physical quantity can be sensed by sensor. So those value can be converted in the form of electrical quantity. So it is a temperature, actually temperature is a physical quantity. So those temperature can be sensed by the sensor. So those physical quantity can be converted into a electrical quantity. So that is called as a transducer. Okay, so that is the primary sensing element. So next one is the second one is the variable conversion element. Second one is the variable conversion element. So in this block, so whatever the, for example, previously we can consider the temperature. So whatever the physical quantity we can measure, those physical quantity sensed by the sensor, those value can be converted into the electrical. So this electrical signal can be transferred to the primary sensing element to variable conversion element. So in this variable conversion element, so whatever the electrical quantity coming from the primary sensing element, same amount of or same signal can be converted the conversion element. So those electrical quantity can be transferred to the variable manipulation element. Variable manipulation. So in this variable manipulation element, so whatever the electrical quantity coming from the conversion element, so without losing any data present in the electrical quantity, those value or those electrical quantity data can be manipulated in the variable manipulation element block. So after that, those quantity can be transferred to the data transmission element. So in this data transmission element block, this data transmission element block. So whatever the electrical signal carries the data, so those data either in the form of analog or digital, so those data can be transmitted in this block. So whatever the analog or digital data coming from the data manipulation element, so those data can be transmitted either in the form of analog or digital by using the channel. This channel may be a different types. So we can use either wired channel or can use wireless channel. Based upon the type of channel, you can transmit the data either in the form of analog or digital. So those coming from the channel, so whatever the data coming from the data transmission element, so those data can be presented in the last channel, that is the last one is the data presentation block. So this is the basic block diagram of instrumentation. So next one is the performance characteristic. So for measuring any type of quantity, we can use instrument. So how we can select the instrument? So for selecting the instrument, so every instrument having a some certain characteristic. So based upon the characteristics, we can select the instrument. So these instrument characteristics, can be classified into two types. So the first one is the static characteristics, second one is the dynamic characteristics. So what is meant by static and what is meant by dynamic? So static characteristics means it is a varying process with respect to time. So whatever the quantity we can measure by using the instrument, so those measurement cannot be varied with respect to time. So those type of characteristics we can call it as a static characteristics. Second one is the dynamic characteristics. So it is a varying process with respect to time. So that means these dynamic type of characteristics can be varied with respect to time. So this is the two types of characteristics. So in this static characteristics, so we already discussed which are used to measure an unvarying process condition. So here in this static characteristics we can measure the quantity either one form or another form or another form. So this process we can call it as a calibration. So in both static and dynamic we can measure any type of quantity. Okay now, so those quantity can be measured in the form of any type of energy or any type of signal. So this process we can call it as a calibration. So calibration means it is a process of adjusting or verifying the accuracy value. So whatever the parameter so whatever the physical parameter you can measure, so those measurement appears at the final output device is a accurate value, then only that instrument is a perfect instrument for measuring the quantity. So in this static characteristics, so we are having different types of static characteristics. So here, so first one is the accuracy, resolution, precision, expected value, sensitivity, threshold, error. So all these are the different types of static characteristics. Here first initially we can briefly discuss about the all types of characteristics. So in this first one is the accuracy. So accuracy means whatever the exact value we can measure by using the instrument. So that is called as a accuracy. So accuracy means it is exactly 100% result it can be produced. So next one is the resolution. So resolution means smallest change in the input to produce related output. For example, you can change the input value from 0 to 0.5 volts. So it is a smallest change in the input, but whatever the change appear in the input, so regarding it can produce the output value. So that is called as a resolution. Next one is the precision. So precision means it is a consistent or repeated value. So that is called as a precision. So that means, so your output is 10 volts. So you are measuring 1 to 6 times you can measure the value quantity. So out of 6, every time it matches, or most of the time it matches the accurate value. So then only that instrument having a precision. Next one is the expected value. So for every circuit we can design, so it can produce a some design value. So that is called as a expected value. Design value for the any type of circuit, that is called as a expected value. Next one is the sensitivity. So sensitivity means it is a ratio of output by ratio of input. So that means, for example, we can consider two voltage values V2 by V1, same as terms of output. So V2 minus V1 in terms of, so that is called as a sensitivity. So next one is the threshold value. So threshold means whatever the minimum value, whatever the minimum value that instrument should start the respond. So that is called as a threshold value. Last one is the error. So error, as usually, it is a difference between expected value, difference between expected value and measured value. So that is called as a error. So all these are the different types of static characteristics. So these are the definitions. Accuracy, the degree of exactness or closeness of a measurement compared to the expected value. Next one is the resolution, precision, expected value, sensitivity, threshold, and error. So next one is the how. Here the main one is the error. Based on the error only we can measure the accuracy value. How we can measure the accuracy value based on the error? So first, what is mean by error? So this error we can call it as a static error. We can call it as a static error. So this static error can be expressed in terms of either absolute error or percentage of error can be expressed. The static error can be expressed in terms of absolute error or percentage of error. So as usually, whatever is the definition of static error, it is the difference between expected value and measured value. So this absolute error, small e, absolute error, small e, equal to yn minus n minus, here small e is the absolute error, so yn equal to expected value, 1 equal to 10 equal to 10 equal to measured. So the difference between the expected value and the measured value we can call it as a error. So next one is the percentage of error equal to absolute error by expected value to 100. So small e by yn to, so this is called as a percentage of error. So by using this, once we can calculate the error, so by using this error value we can calculate the accuracy value. So how we can calculate the accuracy value? Capital A equal to 1 minus error, yn minus xn by xn. So this A we can call it as a relative accuracy. So by using this relative accuracy, you can calculate the percentage of accuracy. Small a equal to capital A into 100. So this is called as a accuracy by using the error. So absolute error equal to yn minus xn, expected value minus measured value. Percentage of error equal to absolute error by expected value into 100. So by once we can calculate the error, we can measure the accuracy by using the error value. Capital A equal to 1 minus yn minus xn by yn, mod of yn minus xn by yn. So by once we can calculate the relative accuracy, so we can calculate the percentage of accuracy. Capital A equal to a relative accuracy into 100%. So next, you can calculate the precision also. So precision P equal to, so already we discussed about the precision value. So what is meant by precision? Repeated set of measured values. Repeated set of measured values. That means we can measure x1, x2, x3 and so on, xn values. N number of measurements we can measure. So that means how we can calculate the precision value by using the n number of measurements. 1 minus xn bar by xn bar. So that is the precision formula. So xn means nth value of measurements. So for example, you can consider 10 measurements. x10 is the xn value. So n equal to 10th measurement. So xn bar equal to average set of measurements. So that means you can calculate 10 measurements. So x10 equal to average means x1 plus x2 plus x3 plus and so on, x10 by n number of measurements. That means, so this is the xn bar, average set of measurements. Precision P equal to 1 minus xn bar by xn bar. Thank you. We will discuss it.